For centuries, the pyramids of Egypt have left us awestruck and mystified. How did a civilization over 4,500 years ago, with seemingly simple tools, build monuments that still defy explanation? The old story is one of brute force and endless labor. But what if we've missed the real secret? In 2025, new research on the Step Pyramid of Djoser at Saqqara has revealed evidence of a sophisticated hydraulic system. This wasn't just about irrigation. It was about using water as a construction tool, a liquid engine to lift multi-ton stones. If true, it means the Egyptians mastered hydraulic engineering long before the Romans. The Saqqara Plateau may have functioned as a massive water-powered construction machine, its evidence hidden in plain sight for millennia. We're finally beginning to see the pyramids not just as tombs, but as monuments to ancient innovation. Before Giza, there was the Step Pyramid of Djoser, the world's first large-scale stone structure. Traditionally seen as a sacred necropolis, Saqqara's true genius may lie in its location and engineering. New findings suggest Saqqara was chosen for its unique hydrological advantages, built around a wadi that flooded with the Nile's annual rise. The builders didn't fight the floods, they harnessed them, turning water into their greatest resource for heavy lifting. The complex's walls, courts, and trenches weren't just ceremonial. They were part of a high-tech water management system. Every element had a purpose, forming an integrated construction ecosystem. The Step Pyramid marks the leap from mud brick to stone, and the hydraulic hypothesis finally explains how they made that jump. Traditional ramp theories never quite fit the scale or logistics. This new theory reveals the Egyptians as master engineers, solving problems with elegance and ingenuity. The Step Pyramid stands as a monument to a technological revolution. To the west of the Step Pyramid lies Gizr el-Mudir, a massive, mysterious wall that has puzzled archaeologists for generations. Its sheer scale and enigmatic presence have long invited speculation about its true purpose. For decades, it was dismissed as an abandoned enclosure, a relic of a failed project. But recent discoveries have rewritten its story, revealing that Gizr el-Mudir was, in fact, a colossal dam. One of the earliest and most ambitious hydraulic structures in ancient Egypt. This dam ingeniously captured the seasonal floodwaters of the Nile, creating a vast temporary lake. At its peak, it could hold enough water to fill over 150 Olympic swimming pools, a staggering feat for its time. Suddenly, the wall's purpose is clear. It was the power plant for pyramid construction, storing the energy of the Nile's flood and transforming it into a resource for building wonders. The artificial lake turned Saqqara into a bustling waterfront construction zone. Barges could now float massive stone blocks directly to the pyramid site, reducing the need for laborious overland transport and speeding up construction. Far from being a failure, Gizr el-Mudir was the cornerstone of a visionary engineering plan, one that showcased the Egyptians' ability to harness nature for monumental projects. Building such a dam required not only immense labor, but also a deep understanding of geology, hydrology, and water management. The Egyptians studied the land, the flow of the Nile, and the properties of stone to make their vision a reality. The Egyptians didn't just adapt to their environment, they boldly reshaped it, transforming arid desert into a landscape that could support their monumental ambitions and sustain their civilization. This dam was the first step in a sophisticated hydraulic process that powered the construction of the pyramid, setting the stage for even greater feats of engineering. It stands as a testament to their extraordinary foresight, meticulous planning, and the ability to coordinate massive projects on a scale never before seen. In harnessing the Nile's lifeblood, the Egyptians were not just building monuments, they were terraforming the desert, using water to build a stairway to the stars, and leave a legacy that endures to this day. Encircling the Step Pyramid is the so-called dry moat, a vast trench, long misunderstood by historians and archaeologists alike. For centuries, its true function was shrouded in mystery, dismissed as a symbolic feature or a defensive barrier. But recent research has revealed a far more sophisticated purpose. Far from being dry or merely symbolic, this trench was the control center of the water system, functioning like an ancient water treatment plant, an engineering marvel thousands of years ahead of its time. The moat's basins and compartments were carefully designed to slow the floodwaters from the Nile, allowing sediment and debris to settle out. This process provided clean, filtered water for construction and daily use, a necessity in the harsh desert environment. This process, called decantation, was essential for the hydraulic lifts to work. Without it, the machinery would clog and fail, halting all progress on the pyramid. The moat also regulated water flow and pressure, acting as a series of locks and valves. These features allowed the Egyptians to fine-tune the movement of water, adapting to seasonal changes and unpredictable floods. Too much pressure could destroy the delicate stonework, too little and the lifts wouldn't function. The balance had to be perfect, requiring constant monitoring and adjustment. The dry moat was the brain of the operation, ensuring water power was applied with precision. It was a dynamic living system, not just a static ditch. This transforms the moat from a passive barrier to a vital piece of industrial technology, integral to the pyramid's construction and the daily life of the workers. The Egyptians weren't just moving water, they were managing, purifying, and pressurizing it with remarkable skill. Their understanding of hydraulics was both practical and innovative. They created a closed-loop system, turning muddy floodwater into a controlled power source. This system minimized waste and maximized efficiency, a testament to their ingenuity. The moat's true purpose was to let the power of water in, clean and controlled, fueling the construction of one of history's greatest monuments. It's a stunning example of ancient fluid dynamics, proof that the Egyptians were not only master builders, but also pioneering engineers in the science of water. With a massive reservoir and a sophisticated water treatment plant, the ancient Egyptians harnessed the power of water in ways that still astonish us today. But how did they actually lift those enormous stones, some weighing several tons, to such incredible heights? The answer lies in a remarkable feat of engineering, a hydraulic lift system, centuries ahead of its time. This system used vertical shafts and a network of underground tunnels at the very core of the pyramid structure. Water was carefully channeled into two large sealed shafts, creating immense pressure deep within the pyramid. These shafts formed a giant U-shaped tube, a monumental hydraulic press. By adding water, the Egyptians generated powerful upward pressure, which allowed them to lift massive stone blocks on specially designed floating platforms, almost as if the stones defied gravity. This was, in essence, a water-powered elevator, an ingenious mechanism that made the impossible possible. It enabled the raising of massive weights with minimal human effort. Instead of relying on enormous external ramps, construction could happen from the inside out, right at the heart of the pyramid. Stone blocks were lifted through the core, and then slid precisely into place, fitting together with astonishing accuracy. This method was not only efficient and safe, but it also protected workers from the dangers of external construction. It eliminated the need for colossal ramps, which would have been difficult to build and maintain. The hydraulic lift system explains the incredible speed and precision of pyramid construction, as well as the mysterious network of tunnels beneath the pyramid. These passageways weren't just tombs or ceremonial spaces, they were the engine room of construction, the hidden machinery that powered the building of these wonders. The pharaoh wasn't just building a monument to his reign, he was commissioning a machine, an extraordinary device, to build it for him. This innovative use of water power reveals a level of mechanical thinking and engineering prowess never before attributed to the ancient world, forever changing our understanding of Egyptian ingenuity. For generations, ramps have been the default explanation for pyramid construction. But ramp theories, straight, spiral, or internal, struggle with logistics, scale, and practicality. A mile-long ramp would have been a massive project itself. Spiral ramps make maneuvering blocks nearly impossible. Internal ramps can't explain moving the largest stones through tight spaces. All ramp theories require enormous resources and manpower. The hydraulic lift theory, by contrast, is elegant and efficient, using water, not brute force, as the main power source. The Nile's annual flood provided renewable energy, making construction faster and more sustainable. Human labor was still needed for quarrying and finishing, but the hardest part, lifting blocks, was solved by water power. Short ramps and levers likely helped on each level, but the hydraulic lift tackled the vertical challenge. The debate is shifting. Were ramps ever the primary method, or did water do the heavy lifting? The answer could rewrite everything we know about ancient engineering. If the hydraulic theory is proven, it rewrites the history of technology. It means the Egyptians mastered hydraulic engineering millennia before the Romans. This discovery reveals them as rational scientific thinkers, keen observers and fearless innovators. They didn't just pray for the Nile's flood, they measured and engineered it to serve their goals. By harnessing a renewable force, they created a powerful, sustainable system. Their dam was a temporary power source, leaving minimal impact on the landscape. This forces us to respect the intellectual capabilities of ancient civilizations. The pyramid builders were not just laborers, they were scientists, engineers, and project managers of the highest order. This new theory isn't just speculation, it's backed by rigorous, multidisciplinary science. Xavier Landreau's team connected evidence from archaeology, geology, and hydrology to see Saqqara as an integrated machine. Soil analysis confirmed seasonal flooding. Geotechnical studies showed the dam was built to withstand immense water pressure. The dry moat's basins match the design of a decanting system, not a defensive trench. The structures themselves reveal their true purpose when viewed through the lens of fluid management. The findings, published in a respected scientific journal, pass strict peer review. This isn't a sensational claim, it's a serious hypothesis supported by interconnected evidence. Modern science is finally unlocking the secrets of ancient engineering. The case for water power at Saqqara is built on a foundation of evidence, not fantasy. As with any radical discovery, the hydraulic theory has sparked intense debate. Some scholars remain skeptical, noting the lack of direct depictions of such machines in Egyptian art. Proponents argue that the most crucial parts, the shafts and tunnels, are hidden and easily forgotten over millennia. This debate is healthy, driving new research and fresh perspectives. Archaeologists will now search for more direct evidence, wear patterns, remnants of caissons or seals for water pressure. Every argument pushes us closer to the truth. The Step Pyramid's secrets may just be the beginning. What other ancient wonders used forgotten technologies? The past is not a closed book, it's an ongoing expedition, with new discoveries waiting to change our story.